everyone, and thank you for joining us today for a Safer's Guide to Best Practices for Optimizing Jobs on FME Server. So my name is Holly Coxon, and I'm the FME Technical Support Team Lead. And today I'm very excited to be joined by Malin, as this is her first webinar, so I'll let her briefly introduce herself as well.
Thanks, Holly. Hello, everyone. My name is Merlin George. As Holly mentioned, this is my first webinar presentation. I joined SAFE in October last year, and I've been working alongside Holly as a technical support specialist on the FME server team.
Thank you, Melin. And we also have another FME server specialist, Steve McCabe, who's on hand behind the scenes to answer any questions that you might have throughout this webinar. So please feel free to use the questions and chat panels throughout. And we'll have time at the end where Steve might make an appearance online as well to help us answer some of those questions. But for now, I'm just going to hand back to Elizabeth, as she has a few tips to share on the platform that we're using to host this webinar.
Yeah, thanks, Holly. So if this is your first time in Livestorm, just a couple tips here. If you have any audio issues, you can click that help button on the bottom left, and there's 4 simple steps there that you can take to resolve that. You can share your reactions with us during the webinar. We really like to see those, how you're feeling, what's your reaction during the content. As well, we have the questions and chat tab. So with the questions tab, leave any questions you might have during the webinar there. And then you can also upvote other folks' questions as well that are relevant to you. And the chat tab, you're all using it now. That's great. So continue leaving comments for us there. If you would like to download the slide deck and follow along during the webinar, you can also do that as well. So click that button on the top right of the slides there, and then you can download.
Awesome. Thank you, Elizabeth. So I think at this point we're going to turn our cameras off just to try and make sure the quality of the sound coming through is good for everyone. So we'll see you again at the end of the webinar. Okay. So I want to start off by reviewing the material that we'll be covering over the next hour. So we're going to start by introducing what we mean by optimization in the context of FME Server. And then we'll be touching on a lot of different optimization strategies, including monitoring FME Server activity, improving job performance, scaling FME Server, and job prioritization. And on that final topic, we're going to be presenting a demo before we end with some time to answer any of your questions. So we did brainstorm as a team to come up with these tips, but if we do get to the end of the session and you think we've missed something, then we'd love for you to share this in the chat as well, so that you can share it with both us and everybody else that's listening in. So to start off, we'd like to conduct a poll. So we'd love to hear what your role is on FME Server. So whether you're the end user, whether you're the author who builds workspaces, publishes these to FME Server, or you're the administrator that oversees the system, or if you don't use FME Server yet as well, we'd love to know. We'll just give it a minute to let those votes come in.
All right, looks like we have almost most votes now. And folks, once you've voted, you can also see the results come in live as well on that polls tab.
Okay, fantastic. I think we've got a nice number of votes coming in there. So it looks like about 55% of our audience today are the administrator role on FME Server, and about 30% are the author. And then we have a couple of end users and those of you who are new to FME Server as well. So the information that we are going to be presenting on is mostly targeted towards the author and administrators. So if you don't fall into that category, then you might not have access to deploy some of the tips that we're sharing today. But regardless, you can definitely pass anything that you learn onto the appropriate person in your organization. And if you're new to FME Server, then these tips are definitely great to be aware of for initially setting up any deployment as well. Okay, so optimization is the action of making the best or most effective use of a resource. So in the context of FME Server, we are looking for ways to save time and money by accomplishing more with our FME engines. So optimization in FME Server is an iterative process and requires the continual analysis of your existing setup. But some of the deciding factors for system improvement are job processing time, system resource usage, the number of engines you have available, and business requirements. So I am going to hand over to Milind for our first section. But before I do that, we do just have one other poll to get us started. So we'd love to hear if you know how many jobs are approximately running daily on your FME Server environment. So we've got quite a broad range here. And if you don't know, that's completely fine, as we're going to be, or Mellin's going to be diving into that after this poll anyway.
Seems like a popular one option on this poll so far.
Yeah, looks like most of them have voted, most of the attendees have voted, and we see that most of them have voted for less than 1,000. That's pretty good. It's good that you have knowledge about these numbers, as knowledge is power when it comes to optimization. So yeah, that's really assuring that you're already looking at your job numbers and are well aware of it. So in this world of ever increasing number and complexity of data processing jobs, we are faced with the need to continuously improve and optimize our systems. So it helps to collect and analyze metadata about a job activity and the server host resources. Which brings us to our first topic, job statistics. Monitoring FME server usage enables us to make more informed decisions about how you would like to respond to increased demand, cut costs, and increase job efficiency. Since version 2021, additional job stats have been exposed to show job performance. Some of these stats are total runs, average elapsed time, average CPU time, CPU percentage, and average peak memory usage across all invocations and job runs. We have an article linked here that gives us an overview of these job stats and how they're calculated, so please do check it out. However, if you prefer a pictorial representation of these job stats over a tabular or log format, we have the Server Analytics dashboard for you. The latest version of FME Server includes a job throughput dashboard, and our dev teams are always working on extending this feature. And since the built-in Server Analytics is a new feature and it presents limited information, you can gather all the information necessary to analyze your server usage by using REST API to build custom HTML reports and embed these into your server as dashboards. For example, you can analyze peak memory usage to check if your hardware is sufficient, or use a job duration to calculate ideal engine time. This could help you plan when to set up new jobs to run or know which engines are being underutilized. And it could also be used to help relieve load of other existing queues. And so if your data is telling you that engines are active 24/7 or high priority jobs are starting to have unacceptable wait times, we should start by looking at optimizing our workspace designs. This will reduce the system resource usage, processing and wait time. It will free up engines for other jobs, and finally reduce licensing cost. As the saying goes, any job well begun is half done. While authoring and designing your workspaces, there are various pointers that you can keep in mind that help improve job performance. We would like to reiterate here that this webinar is focused on optimizing FME server and is, as you can see, these pointers are for workspace authoring on FME desktop. But since the underlying technology processing the workspace is the same for desktop or server, any workspace improvement made in desktop will translate to server as well. We have an article that focuses on performance tuning during workspace authoring. So please do check it out yourself or encourage the workspace authors of your organizations to do so. For starters, let's go over a few tips. Make sure you only focus on the required attributes from the required data source. Use transformers like the attribute manager to remove unnecessary attributes as soon as possible in your translation. And avoid grouping transformers that may consume lots of memory, especially when dealing with larger data sets. If you have multiple writers in a workspace, the first writer in the list is the first to write its data, while subsequent writers cache data until it is their turn. Performance is hindered by caching data, so it makes sense to promote the writer handling the most data to the front of the list so that its data is not cached. If you're working with an extremely large amount of data, it can be difficult to process in a single task. You may want to consider partitioning the data into groups and processing each separately. And so if you are working with a long time consuming job, parallel processing in FME could be the answer. Parallelism in FME server is using an automation to distribute processes across engines by creating a workflow design with multiple jobs. This also provides control over job orchestration under queue control. Typically, workspaces process every single feature one by one in classic pipeline processing as shown in the first workflow here. The workflow runs for as long as it takes to process every feature in sequence. On the server, one single engine will be responsible for this job. However, in parallel processing, we split up our data in jobs across our engines, and they work in parallel to get the results much faster. And so the runtime is as long as the longest task, as we can see on the second workflow here. For more details about parallelism in FME server, please check out this fantastic webinar that was presented during user conference this year. Another avenue for server optimization is server hardware. Now, when it comes to hardware sizing for FME server, there is no hard and fast rule and no accurate means to determine it before deployment. It will depend on the types of workspaces, workspace design, and what resources they use. However, we do have a technical spec available online, which provides the compatible operating system versions and the recommended CPU, RAM, and storage requirements. Most server components have relatively smaller footprints and take up small percentage of CPU and memory. For the core and application server, these can function well with 2 GB of RAM and 1 core or 2 cores. One CPU each for core and web application is the ideal scenario, however. When considering storage for server, please do consider storage that is required to install the server, which could be around 20 to 25 GB. And also consider systems resources for other third-party applications and system processes running on your host. Moving on to the most resource-consuming component of server, the engine. As a rule of thumb, we recommend one CPU core per active engine on your installation. Now, depending on the number of workspaces, their complexity, the resource utilized by jobs, under-provisioned engines could face memory or CPU errors and your jobs might crash. For analyzing CPU and memory requirements for your engines, the best place to start is by reviewing workspace logs. For workspaces already published on the server, you can check out the jobs completed web page to find individual job stats in a tabular format. However, if you're provisioning the server for a new workspace, you should look at the bottom of the workspace logs in the workbench. you'll see resource usage parameters introduced in the previous slides, like the CPU usage time, system usage time, peak process memory usage, current process memory usage, etc. You can go through this article for more information on these parameters and how to interpret it for engine provisioning. Continuing our discussion on engine requirements, for high data input-output rates, consider using SSD storage for the engine host local cache or temp storage. When FME is usually running a large translation, it requires a lot of temporary disk space. So wherever possible, try to use a different disk to the one used by the operating system. Setting the FME_temp and FME_home paths to a network drive results in performance degradation mostly. As of FME 2022, a warning in the log will appear if these paths are set to a network drive. So for optimal performance, ensure that these paths are local. You can follow this FME community article that shares how to set the FME_temp environment variable. And finally, once you have the engine CPU, RAM, and memory requirements, please consider your engine location with respect to your data. Reading and writing workspace data is one of the largest bottlenecks when running translations. So if you're reading from a database over a slow network connection or from a database service hosted in a different region in cloud, it could impact job performance. Ideally, the data set should be on the FME engine host, or you should be able to set up reliable and fast network connection between the engine host and the data. We can also use network-based or cloud-based resource on the server web UI for uploading and storing data closer to your engine. This process includes mounting a file share onto the server host and then creating a new resource connection on the server web UI using a local UNC path. You can also connect an Amazon S3 bucket as a resource. Please check out this article for more information. And now for the next section of our webinar, I'll be handing it over to Holly.
Thank you, Malin. Okay, so now we're going to be looking at if you've already walked through all the steps that Malin has outlined and you've worked on reducing the duration and the runtime of your jobs and increasing that performance, but you're still in a position on your FME server where you're not able to deliver your jobs in a time frame that is optimal for your business requirements. So if your throughput is still exceeding that capacity, then you'll likely need to provide additional engine capacity to your FME server environment. So that means it's time to scale. And so FME server supports two different engine types, standard and CPU usage, also known as dynamic engines. So I'll just start by noting that when we first released the second engine type, we did refer to this as dynamic engines, but we're now shifting to using the term CPU usage, as this is a better reflection as to what this engine type actually is. But so in this webinar, I'm going to be referring to them as CPU usage or dynamic to try and avoid any confusion as to what you're seeing in our product and our marketing materials. So these engines are identical from a technical standpoint, but the difference lies in their pricing model. And so this is a really important consideration when you are considering scaling your deployment to ensure that you're only paying for what is actually needed. So standard engines follow the traditional pricing model, whereby you purchase a fixed engine that is permanently available to process jobs. So if you are exceeding capacity at a regularly occurring interval, then this is likely the route to take as your overall FME server demand has increased. However, CPU usage or dynamic engines follow a credit pricing model, which makes them ideal for varied and unpredictable workloads, as you can spin up as many engines as you'd like for any duration of time, and you'll only be paying for the CPU time that they spend actually processing jobs. So let's take a closer look at this engine type. So firstly, what do we actually mean by CPU time? So if we take a look back at the job statistics Merlin presented on earlier, we record both the elapsed and the CPU time. So the elapsed time is the total job duration, but the CPU time is the user and system time the engine spends doing work on the CPU. Things that are not working on the CPU are waiting for input, waiting for network or disk. And so depending on the transformation, the CPU time will vary. And this could actually make up a very small proportion of the overall duration. So there are a few benefits to this pricing model. Firstly, it allows for that scalability, that flexibility to launch as many engines as you'd like as your workload increases to maintain a responsive FME server system. Of course, we also see reduced costs, both monetary, as you're only paying for the time those engines are processing jobs, as opposed to a fixed license, but also reducing those costs to that end user. There's less of a wait time for end users to receive results, which also improves that overall customer experience. It also allows you to be agile and to address your ever-changing processing needs that stem from the variety of different automated tasks running on your FME server system. So how can we actually meet these varying processing needs? We need a solution where we can prioritize jobs and reallocate engines based on this throughput so that we don't need to have be paying for more than what we actually need. So the challenge with scaling and the number of engines that you need on your system is that jobs are submitted by automated processes and on demand by end users, resulting in a system load that is highly variable and changes over time. So in this graph, we can see that, well, it's a little bit small, but this is an example of job throughput through server analytics. So we can see that there are certain times of day where we're actually running a few thousand jobs, and then overnight we're not running any jobs at all. So in this scenario, in order to meet this peak, it doesn't make sense to purchase standard engines, because then we're going to have them sitting idle for all of these hours overnight instead. So instead, we want to look into this dynamic engine model as well. And we also want to be able to reallocate engines based on the incoming jobs so that we can prioritize these and make sure that the jobs that need those quick wait times are being prioritized. So there are 3 steps to this job prioritization that are commonly referred to as queue control in FME Server. So first, we have to define our queue. So queues are a central component to job control in FME Server. FME Server is installed with a single default queue, and all jobs submitted are handled by this queue, and they will run in the order that they arrive into the queue. However, you can, as an administrator, define additional queues with differing priorities. And then once you've defined this queue, there are actually 2 additional sets of rules that need to be defined, and these control how jobs and processing resources can be allocated to these queues. So firstly, we have our job routing rules, and these control which queue a job is actually sent to. So jobs can be routed based on properties such as repository, the workspace name, the source type, or they can also be routed based on those historical job statistics. So for example, you could route jobs based on the CPU time to ensure that only those low CPU jobs are the ones that are being processed by your dynamic engines. And then we have to define engine assignment rules as well. And these control which engines are allocated to a queue. So engines can be assigned to one or more queue based on their properties. For example, the engine type, the operating system, the host name. But importantly, they can also be assigned based on queue properties. So the allocation is not permanent, and this allows for that agility and that flexibility to move engines around based on this varying load. So shortly, we'll be running through a demonstration to actually show how you can configure these three to work together to handle a varying job throughput. But before I dive into the demo, I wanted to walk through some use cases. Because the most important takeaway is that regardless of the intended use case, all the configuration steps are the same. So some common use cases that we've seen with regards to queue control are to provide additional processing resources for big data lifts. Or alternatively, if you want to partition FME server by department, then you can route jobs to different engines. You can also ensure minimal wait times to that end user if you have any workspace apps configured by dedicating engines to those processes. And it also allows you to optimize any hardware or licensing restraints that you have. So if some of your workspaces require access to an ArcGIS license, but you have a distributed FME server deployment, you could set that license up on just one of your hosts and route all of your jobs to that host for processing. So now we're going to move over for the demo. And this demo was actually pre-recorded. I didn't want to risk doing it live and having some technical hiccups. So I'm going to hand over to Elizabeth to play that for us. Okay, so here I have my FME Server homepage, and I'll be using FME Server 2022.1 for this demonstration. So the idea behind this demonstration is that I am going to be simulating a heavy load to my FME server system. So I'm actually going to be making use of an automation here to trigger almost 1,000 jobs. And this is going to put my FME server under some strain. By default, I only have 2 standard engines. And so by submitting 1,000 jobs into this queue, these are going to occupy these standard engines for quite some time and potentially force other jobs to experience long wait times. So what I'd like to do is allocate additional dynamic engine capacity to take on the job load and allow more workspaces to run in parallel so that these jobs are completed in a quicker time and so that they're not occupying those standard engines for a long period of time where other jobs are unable to run. So in order to do that, I'm going to go over and configure a queue. So I'm going to head over to my engine management page, and firstly, let's have a look at our existing engines. So I currently have 2 standard engines available, and they are running the jobs that are being submitted to the default queue. And then I currently have 6 dynamic engines enabled, and they are going to be running any jobs sent to this dynamic holding queue. And actually, the way that I've set up my FME server, this queue will never receive any jobs. So the intention is that this is the home for the dynamic engines, and they will not run any jobs when they are assigned to this queue. So this ensures that I'm only going to be paying for these engines and using them when my standard engines are not available. So what I'm going to do is I'm going to create a new queue that's going to handle all the jobs being submitted via my automation. So rather than being sent to the default queue, I'm going to set them up to be routed to this automations queue. And I can do that by creating a job routing rule. So I'm going to create a new rule, and I'm going to give it the same name as my queue. And then here I have the option to set a rule based on a variety of different properties, as I mentioned. And I'm going to be using the source type. So I'm going to say if the source type is an automation, then this job should be sent to my automation queue. Now, this is going to send jobs from all automations to the queue, which is okay for my scenario. But if you do have automations with different priorities, then you can also set it based on the source name as well. So you can go right down to the individual item to control this. So now I have jobs that I'm going to submit for my automation being sent to this automation queue, but currently I don't have any engines assigned to that queue. So what's going to happen is all of those jobs are just going to pile up in this queue and never actually be processed. So I'm going to head over to my engine assignment rules now, and I'm going to create 2 additional queues to handle my standard and my dynamic engines. So I'm going to create my first queue for my standard engines. So what I'd like to do is I would like to assign one of my standard engines to the automation queue. So I'm going to do that based on the name. And the reason that I'm doing this is because I don't want all of my standard engines to be occupied by this automation, because that means they won't be available to run those jobs that are also sitting in the default queue. So I'm saying I'd like one to remain only with the default queue and one to handle jobs from both the automation and the default queue. And then the second thing that I need to do is create a rule for my dynamic engines. So I'm going to do the same thing here, dynamic engine automation. And this time I'm going to create a rule based on their property engine type. So I would like to assign all engines that are dynamic to the automation queue. But if I do this as it is, then what will happen is those dynamic engines will be permanently allocated. And so they might end up processing jobs when the standard engine is sitting there idly and could have been processing them. So I want to make sure that I'm only paying for this additional capacity in scenarios where I need it. And to do that, I'm going to create a queue property to watch for the number of queued jobs on my automation queue. And then I'm going to set a threshold. So I only want the number of the dynamic engines to be assigned to this automation queue if the number of jobs exceeds a certain threshold. So let's say when it exceeds 10 jobs, that's when I want my dynamic engines to also be pushed over and for processing jobs for my automation. So now let's go and just take a look at what we've set up. So at the moment, we've got our first engine is processing from the default and the automation queue. Our second standard engine is just the default queue. And currently our dynamic engines are just the dynamic holding queue. So what I'm going to do is trigger that automation, and we'll see that as the queue exceeds my threshold, this value gets updated and my dynamic engines start processing my automation jobs. So I've triggered my automation now, and it's going to spin up these jobs fairly quickly. So we're going to head over to the queued page, and we're not quite over our threshold yet, but if I just refresh it, we'll soon see that the number of jobs is definitely piling up there. So let's take a look back on our engine management page and see what's going on. So at the moment, you can see that just our one standard engine is processing this automation. So there are periodic checks that are made on the queues and the engines, and we'll soon see, yeah, here we go, that the dynamic engines have now been assigned to that automation queue. So now we can see, and you'll see that after a certain number of jobs are run, engines are restarted. So you'll see this page does shift slightly as engines are being brought up and down again. But all of our engines are now running those automations as well. And once we reduce below that threshold, so once the number of jobs waiting is below 10, this queue will be removed and our dynamic engines will go back to just waiting in that holding queue. So that was an example of setting up job control in order to prioritize jobs coming from different sources, provide additional engine capacity using our engine assignment rules, and in this scenario, our dynamic engines as well. But there's lots of flexibility here, which allows you to prioritize jobs and make sure that you're optimizing the engines that you have available to you to make sure that jobs have shorter wait times. Okay, thank you to me, I guess. So that brings us to the end of the information that we wanted to share with you all today. So a few key takeaways here is that optimization in FME Server is a never-ending task as new translations are being put into production and your business and processing needs change. So analysis of your FME server activity is key for optimization. And this practice can help ultimately to save your business both time and money. And then takeaways to specific users out there listening today. If you are a workspace author, then you should be designing workspaces with FME Server in mind to ensure that those jobs are following the most performant practices. And for FME Server administrators, you are responsible for ensuring adequate hardware provisions and also any job prioritization configurations on your system as well. So yeah, in terms of takeaways from this webinar, we'd love to chat to you about your FME server. So please feel free to reach out to us. And again, if you have any other optimization tips, please share those in the chat with our other listeners as well. But yeah, we encourage you to go away and analyze your FME server job activity and your existing engine utilization and see if you can apply any of these tips that we've discussed today. So a lot of the things that we touched on today were only covered at a very high level because there was lots of information that we wanted to share. So we do have lots of resources available where you can learn a little bit more about what we've spoken to. Some of these are articles. I think there's a couple of webinars and talks in there as well. So you can download the slide deck by hovering over this presentation, and there'll be a button in the top right-hand corner. But we'll also be emailing this out to everyone that signed up for this webinar afterwards as well. So you should have access to all of those links there. And I'll let Elizabeth speak to this slide.
Perfect. Thanks, Holly. So as a thank you for you all joining us today, we have a community badge code, which I'll drop in the chat here. If you aren't a part of our community, we really encourage you to check it out. It's a great place to connect with other FME users and gain solutions to your problems. As well, if you have not checked out safe.com/webinars, we recommend you do so. There's lots of great other webinars on demand and upcoming webinars as well. safe.com/webinars. And with that, we do have about 20 minutes remaining here for some Q&A. And thank you to everyone for all the questions you left in the chat there and the questions tab there. That's awesome. At this point, we'll turn back on our cameras and take a look over those questions.
Fantastic. Thank you, Elizabeth. So I'm not sure, Steve, you're welcome to join us as well if you'd like to, but no pressure. So just going to have a look through some of the questions here. And I guess I'll start by trying to answer some of the ones that we weren't able to address during the session. So there are a couple of engines about standard and dynamic engines and how you go about purchasing these. So when you purchase FME Server, one standard engine is included. So you'll always have at least one standard engine accessible on your environment. But then with regard to scaling and adding additional engines, the options would be to purchase additional standard engines or to purchase credits. And so you can have a combination of standard and dynamic engines on your system. And then when you purchase credits, you can launch as many dynamic engines as you'd like. So really the route that you, or if you're looking to scale, then the option that you take is going to be very dependent on what your FME server is processing and your needs. And in terms of pricing, buying more standard engines might make more sense if you know, that engine is continuously going to be in use. But if it's only to meet certain requirements, so only when you know, a certain server app is run, or you have maybe a streaming workflow, then dynamic engines might, or CPU usage engines might be the option that you go for. So if you're looking to make that decision, I definitely recommend that's where you really want to be monitoring your job throughput and the activity that's taking place on your FME server to help you make that decision. Steve, I'm not sure, were there any questions that you answered that you'd like to kind of raise with everyone listening?
There was a great question about calendar view. For schedules, upcoming schedules, seeing a live view of what's coming up and maybe where there's possible clashes of too much demand. So I shared a couple article links, but I know we tried this a few times. We don't have anything active right now in the UI, do we?
Yeah, we don't currently have anything active. It is something that our development team has looked at over the years. With varying success. But I think ultimately it wasn't something that we were able to complete in the manner that we wanted to. So there isn't currently anything available, but if that is something that you're looking for, then we definitely encourage you to add feedback to there's an existing idea on the community. That's really going to help to move this forward. And there is also an existing article on the community. It is a couple of years old now, and I'm not sure anyone from our team has tried to follow those steps recently, but it allows you to embed a calendar view from, I think it's Google Calendar, to present it as a dashboard as well. So that's a more advanced option because it looks like you probably have to use the REST API and things like that to build some kind of workspace that generates that.
Yeah, precisely. Thanks for adding a bit more context around my responses. I found 2 articles that were related to showing some kind of result in a calendar view, as well as the idea. So everybody vote on that idea, because it would be fun to have that there.
Yeah, and I'm going to message our product manager after this and say, hey, this was asked for again. Is there any movement there? Yeah.
There's Mac just added a comment or a question, and I'll just add to that. There is a comment on one of those that says that a customer is using Office or Office 365 to schedule jobs. So that's pretty cool. I don't know how he's doing that, but
that's cool. Yeah, I think the article we have is because we use Google at Safe, but I suspect it probably is possible with other email providers, as long as they have like a REST API for you to interact with. Yeah. Okay. Okay. Yeah. So just looking, there's a question about an automation that needs to, they need to process only one job at a time. And so they need to make sure that these jobs actually aren't running in parallel if there are multiple engines. So the first thing, if there is a requirement that jobs run one after the other, then you should be able to configure this with an automation alone. And because you can chain jobs based on the previous job translation result. So you basically set it up so that the jobs that needed to come later were connected to the success port of that first job. And so the jobs wouldn't even be submitted into the queue until that first one was finished. So you don't need to set up any special queues. That can all be routed to the default. You don't need to dedicate a specific engine to that process. Just the automation alone should be sufficient to get those in the correct order.
But to add to that, if your requirement is for the automation to be triggered by some external resource and you don't know precisely when that's going to happen or how often it's going to happen, then you may want to have a queue dedicated for that engine, that job processing, so that you don't overwrite something that can't be overwritten at the same time. For example, an Excel spreadsheet is in the question, one of the questions.
Right.
So
yeah, that's a great point.
Yeah. Automations is really where everybody should be going these days. There's the old notifications and publishers and subscribers, but automations is really changing how we can pull things together very quickly graphically in the web UI now.
There's a good question here about FME server versions and what's applicable that we showed today to different FME server versions. So we've tried to kind of note when things were introduced, but I'll try and highlight that now as well. So in terms of monitoring job activity, the job statistics were exposed in FME Server 2021, and the server analytics, the job throughput, was exposed in FME Server 2022. However, we have had these kind of dashboards page going back, gosh, longer than I've been at Safe, so at least back until around 2017. I believe they've been in the product even earlier than that. Yeah. And so you can absolutely build your own dashboards by calling the REST API and in a workspace, kind of doing that analysis. And one of the articles that we've linked does give a demonstration on how you can build those dashboards. And then in terms of improvements to job performance, so all of those modifications on FME Desktop, hardware, that's applicable to all versions. There's nothing specific to any one version there. And then in terms of dynamic and standard engines, the dynamic engine pricing model is available as of 2020. And then the queue control has been in the product for a long time, but it was revamped in 2020. 2021. So what I showed today is from 2021 and newer. In older versions of FME, it was more limited. So you could allocate jobs based on their repository. You couldn't use these job statistics or the source type or anything like that. And then in terms of the engine allocation, it was just based on the engine name. So again, no other engine properties there. Maybe what I'll do is I'll see if I can just add a note in all of the slides. And Elizabeth, before you email those out, perhaps, so that everybody has that noted down as to what's applicable to them.
Yeah, definitely.
Yeah, that's a great idea. Thanks for the question.
Yeah,
there's a new question on automation versus scheduling. Can scheduling of jobs play an optimization role as opposed to automating all jobs?
Mm-hmm. So. Yeah, I would say it's automation versus scheduling is very dependent on the actual requirement of the job that is being run. So if you have jobs that are just doing like a daily update, a sync of data from one place to another, then it might be beneficial to put those on a schedule overnight when you don't have anything else coming into your system. But there are definitely jobs where you're probably going to have to go down the automation route if you need them to be triggered in this near real time, to be processing data being dropped into a file or sent in by email. But yeah, so I would say it really depends on what is an acceptable wait time for the job being processed. Because absolutely, like even monitoring like a file, that could be done whenever a file gets dropped in. Or if it doesn't need to be done immediately, you could have that on a schedule, just reading the file, the folder nightly. So yeah, kind of very dependent on what that acceptable wait time is for your business.
And I think too, it's wise to pay attention to the scheduling occurrence, because you could have multiple durations of schedules, once a day, once an hour, once a week, once every month, and you could have a collision of not enough engines to process that work in an overnight fashion, maybe in some cases. So there is that possible perfect storm where you have not enough. So scheduling, looking at the schedules, being able to see those schedules in advance as a calendar view would be very, very helpful. So another kind of shout out to that.
Awesome. Any other questions the team sees here we might want to further address at this point?
Yeah, just having a look through these.
And in the meantime, I'll mention as well, if you do have questions for us that come up after the webinar, we're always happy to chat, info@safe.com. And we will stay online a couple minutes past when the questions are over, just in case you have any last minute additions you'd like to add there. We'll try to get to as many as we can.
I think there's a good question here just about how many engines, how do I know how many engines I have? So this is something that the administrator has access to, and this information is available through the FME Server web interface. And there's a page, it was the page that I went to while I was demonstrating the queue control functionality, and you can see the number of engines that are up And from that page, you can also see which ones are actively running jobs there as well. And that's also the page where you can change the engine count if you do have dynamic engines, or if you have a distributed hosts and you want to move engines around, then that's the page where you can see everything about your engines. There's a good question here. It's slightly outside of today's webinar topic, but I'll address it because it is something that we are the development team is actively looking into at the moment. So there isn't a way, we don't have like a template or anything at the moment. This is something that we have been asked for. But something that our development team is looking into is like a configuration store where you can define a parameter and then reference it in many places throughout FME Server. So it would be a single place to maintain passwords or any kind of setup, and then you'd reference that in your system email and your email in automation as well. Yeah, that's definitely something that the team is aware has been requested, and yeah, I'd love to see that as well.
Any other questions we'd want to address here before I wrap us up here?
I think we've probably touched on most of these now. Yeah, some really great questions.
Yeah, thank you, everyone. And a big thank you to Steve and Richard for joining us on Q&A this morning. We really appreciate it. And to our presenters, Holly and Merlin, special thank you to Merlin for your first webinar with us. You're a natural. It was awesome to have you on board with us for this webinar.
Definitely felt like doing it for a long time.
Yeah, that's awesome. And to our audience as well, big thank you for joining us today. I've recently just left a link in the chat for our webinar survey. If you do have a moment to fill that out, it's just a couple multiple choice questions, and any feedback helps us continually improve the program. I've also left the link to connect with us on the community and try FME or upgrade. So thanks everyone, and we hope that you have a great rest of your day.
Yeah, thank you. And if you do have any lingering questions, then we'll stay online for a few more minutes. So definitely post those as well.
Yeah, and we're always here. So www.safe.com/support.
Mm-hmm. Yeah.
Thanks everyone. Bye for now.